Okay, so we have a homework check tomorrow, okay? And test is next Wednesday and Thursday. So next Monday and Tuesday are test review days. Wednesday and Thursday will be the test. I'll try to have the review ready for you Friday. Probably will, but I don't want to say that for sure. Okay, probably will have the review ready for you Friday, but for sure on Monday, of course. I also say up there something about a unit circle, or no, sorry, a trig quiz. We've been doing the timed unit circle, and that's the last time. We're not doing it again. We are switching to a different type of quiz, which I find much more important than the unit circle quiz. Trig quizzes are timed, of course, and where you have to find, so this is an example of one, but not what you would see at first. So what you guys would see is sine, cosine, or tangent of any unit circle, only unit circle angles, and mostly radians, okay? If I put degrees on there, I'd probably keep it to quadrant 1. So 30, 45, 60, 90 would be the only time I really would use degrees. Otherwise, you would see sine, cosine, or tangent of radian measures. Now, this one is further down the road where you can see there's cosecant and secant on here. And actually, there's cotangent as well. So there's 3 more that we're going to learn. But for now, it would just be sine, cosine, and tangent. So I'm going to review with you at the end of class, like, how to attack one of these. Like, what is the order of operations? Like, because it's intimidating just looking at this, thinking, I'm going to have to do this on a timed quiz. I'll probably do 3 minutes the first time instead of 2 minutes, so let's just say that. But really, it could take a minute if you really know what you're doing, okay? But I'll review with you. And remember, it entails looking at the denominator. So all denominators have the same ordered pair. So you grab that. Numerator tells you the quadrant. Apply the signs. Cosine comes first, sine comes second, and we memorized all the tans. Y over x. So we'll review all of that several times before we do the quiz, which will probably be Thursday or Friday. Okay, but I'll let you know for sure tomorrow. All right, so what today is kind of putting sine and cosine next to each other and kind of comparing their similarities and differences and really zeroing in on all the different characteristics and properties of both. And so if you remember, sine's parent function looks like this, but then we can also add an A in, add a B in, and in fact, you're going to learn that there's 2 more letters, C and D, as we move forward. Same with cosine. You can add an A in, you can add a B in, and later C and D. The only difference is the pattern of the points. So the pattern of sine is middle, up, middle, down, middle, right? It's an intercept, a max, an intercept, a min, an intercept. I like to say just the middle part. I think it's easier. Mid, up, thank you, mid, down, mid, okay? Oh. At first I was thinking you were in this class. I'm like, what? Did you go to the bathroom that whole time? I didn't even know you went to the bathroom. Okay. So that's sine. And remember, if there's a negative in front of our amplitude, amplitude's always positive. If there's a negative in front, our ups and our downs, so up here and down here, would switch places, right? That's what happens. Intercepts never change their place in a flip, okay? You can't flip over yourself, right? So cosine is a different pattern. Up, middle, down, middle, up, middle, down, middle, up. So it's a max, a intercept, a min, an intercept, and a max. So that is up, mid, down, mid, up. You need to know those. You need to be able to look at a graph and say, it's this or it's this, sine or it's cosine. Okay? The domain of both of them is the same. It goes on forever. Okay? We're just graphing one cycle typically. When we do our 5 points, that's just one period or one cycle of these graphs. But we should know that they continue on forever in both directions. Both of them. Okay. Range for both is the same. On the parent function now, this will change when your amplitude changes. This is interval notation. Least to greatest always. You never change the order of that. and brackets mean we're including it. So our lowest and our highest, those are our mins and our maxes on the parent function. Amplitude is the absolute value of A for both of them. And we have a formula for amplitude, which we haven't used a whole lot. We haven't had to. Well, I'll reintroduce it to you again when we get to it. But we've had pretty easy ones. Even when the amplitude requires the formula, it's still not difficult. You just have to know the formula. That would be a good one. These two formulas would be good to add to our formula sheet. Remember, I had my formula sheet taped to the door. The painter ripped it off, so I have to recreate my formula sheet. So I don't know if anyone has one they're really proud of and they like it. So I'd love to copy yours so I don't have to go back and research all the different formulas. And then we'll add some formulas. So if anybody has one that they want to lend me, I would be grateful, and I'll give it back to you like tomorrow. All right, period is for both of these 2 pi. That's the parent function again, okay? 2 pi. Then if we are given a b, it changes that. That's why our formula is 2 pi divided by b, okay? So the period formula is 2 pi divided by b. Remember, period and b are not the same thing. B affects the period. It changes that 2 pi, right? We divide by it. Same thing over here. And something new we haven't talked about yet is symmetry. We have even symmetry, we have odd symmetry. Those are the 2 types of symmetry we typically use with functions. And let's do cosine first, because it's kind of easiest to see. Cosine has even symmetry because it's reflective over the y-axis. If you pictured graphing another one, I'm going to do this poorly, see, awful, but it's embarrassing. Picture that graph over here, and that keeps repeating. So if you folded your graph on the y-axis, all the points, if I could graph correctly, would match up perfectly, okay? So cosine has even symmetry, which is y-axis symmetry. You hear all different ways of saying it. What's the word? I'm trying to say. What? Reflects over the y-axis. It's symmetric about the y-axis, symmetric over the y-axis. Sorry, y-axis. This one is odd. It has origin symmetry, so it's helpful to remember the O's. Origin symmetry, meaning opposite quadrants are the same. And in a minute, we're going to graph into 2 quadrants, so I'll try to remember to go over that again, okay? But that's the symmetry. So I always think cosine's the easiest one to see. So even is sine, the other one. Okay, so key concept, I guess. By comparing the graphs of sine and cosine, you can see that either one can be horizontally translated to obtain the other. Okay, let me explain this after I read. The sine and cosine functions are both sinusoidal functions. Try to use that in your everyday conversations. Sinusoidal functions, and we will prove that cosine x is sine x plus pi over 2. Remember I told you we're going to be introducing C and D to you. This is going to be the letter C, but we don't really get into it until I think 3.6. What this does is translate your graph left or right. It's always opposite, so this is left pi over 2. That's what that means. It's kind of like H in a function, H and K. Okay, but don't worry about that too much, and I'm going to explain what this means exactly in a second. Okay, and here's that full written out form of sine and cosine with the A, the B that we've been working with a lot. I just kind of mentioned C, and guess what? D is what moves your graph up or down. So C and D are like H and K in regular old like polynomials and stuff. They just call them C and D here. But we'll talk more about that later, but I just wanted to touch on it since it was there. Okay, so look at the top of the next page. We've got example A and B. And so I love this page because we're going to review everything that we've pretty much learned that has to do with A and B. Can we find the period from a graph? Can we find the period from function? Can we find the amplitude from a graph? Can we find amplitude from a function? The answer is yes, we all can. We've been doing it nonstop. But before we do that, remember I told you I was going to kind of explain that better about sinusoidal. I literally would have to go to dictionary.com every year to hear it because it's just, that word trips me up. Sinus, like sinusoidal. Okay, anyway, so let's just pretend this is like any other problem. It really is. Find the period. So what do I always say? Well, let's start at 0, 0 and go out how many points? 5. Always 5. It's never going to be 3, 4, 7, 2.5. It's always 5. So middle, up, middle, down, middle. The period of this from 0 to pi is pi. Okay? So period is how much of the x-axis we use for 5 points. One period, one cycle. Okay? So from 0 to pi. The reason I always say start at 0 is because it's distance, right? And 0 out to pi would equal pi. 0 out to 2 pi would equal 2 pi. It's easy math. But technically, you could pick any 5 points, and the distance between them would be pi on this graph, okay? But it's harder to see. For example, if I start here, and I go 1, 2, 3, 4, 5, okay? That graph that I just basically outlined, if you measured it from, I can't see, whatever that angle is to whatever that angle is, it is pi, the distance, how much of the x-axis you're using. But what just changed, though, and I didn't really mention it, the first 5 points that I did, what graph would that have been? So from here, middle, up, middle, down, middle. That's sine. But what I just outlined here is cosine, right? Up, middle, down, middle, down. It's still part of this graph. So if I shifted this, so this is pi over 2. That's what this is right here. If I shifted this to the left, pi over 2 distance, it would be sine, right? If I took my original sine graph and shifted it to the right, pi over 2, I would have cosine. So depending on where you start, you could really have all different types of functions here. That's what sinusoidal means. Let me do one more for you. How about if I start here? 1, 2, 3, 4, 5. Still same period, still part of the same graph, but this is cosine with a flip, right? Down, middle, up, middle, down. You can really find all 4 forms of the graph. You could find positive sine, negative sine, positive cosine, negative cosine, depending on where you start. So when we answer these questions, it's really, there's infinite number of problems that you, and formulas you could use for these. They get really complicated when you have to do shifting left and right, and you're going to see that. Anytime we have to move a graph up and down, that's really simple. But left and right gets very, 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 very tricky. That's why it just makes sense for us always to start at 0 and count 5 points. So up, I think they're coming, up, middle, down, middle, up. Nobody ever comes in my room. I swear, it's like every time that they come, it's like everyone's on their toes. Make sure your boards are filled out. They check to make sure the date is right, everything. And then no one ever comes in my room. I don't know if that's a compliment or an insult. I haven't figured it out yet. But nobody ever comes in, and I hear their voices. Up, middle, down, middle, up. How much of the x-axis did we use? 5 points, right? Without how far? Pi over 2. That is our period. Okay? So I think we've got that. I think we all know how to find the period using the graph. 5 points starting at 0 makes the most sense. Okay? Use the equation to find the period. So this is A, this is B, and the period is affected by B. So if there's a 1 there, like meaning it just said cosine x, our period's 2 pi. That's the parent function, right? But if there is a B value, we have to use this little formula. Change our parent function's period by dividing it by, is that a 5? I'm telling you, turned 50, falling apart. I turned 50 last March, and that's when I needed a new hip, hurt my back, my eyesight went haywire. It's true, literally. It was like days after my 50th birthday. Everything fell apart. Anyway, period is 2 pi over 5. There's no simplifying to do there. But if you could simplify that fraction, you 100% would simplify the fraction. 2/5 can't be simplified. Okay? Same thing here. Guys, what is the b value? When I see x over 3, what's the b value? 1/3, okay? b is 1/3. So understand, because I've had this question, x over 3 is the same as 1/3 x, but it's just cleaner. Remember, we want to condense this. There's enough going on in our level of math. We want to write things in their easiest form. Just like pi over 2 is half of pi, okay? But we don't write half pi. You can say it like that. I've heard people call that half pi. Pi over 2. So anyway, that's 1/3. So our period would be 2 pi divided by 1/3. Now, you're going to start seeing me not show this step. When I know I'm going to divide by a fraction, I skip right to, in my brain, I'm saying it every time, keep, change, flip my 1/3 would be 3 over 1. So that's 6 pi. So understand, when I say show work on certain problems, this is not what I mean. You do not need to show this step. You don't really need to show that step. Most of you could start doing this in your head, or show as much work as you want. So understand what happened here. Period is 2 pi over 5. That means you're only going to use 2/5 of pi. So it's a very small part of the unit circle, very small part of your x-axis, which is the unit circle, to make 5 points. Whereas this one is going to stretch 5 points out over 6 pi. It's going to be a super spread out graph. That's what's happening there. Okay, how about amplitude? Well, I gave you the formula on the that first page, and we've not been using a formula for a problem like this, and you certainly do not need to use a formula to find it, but I want to remind you of it so we know how to use it when we have to. So the amplitude is half of your max minus your min. So obviously the same value of 4 minus a negative becomes positive. 4 plus 4 is 8. And guys, multiplying something by 1/2 simply divides it by 2. So 8 divided by 2 is 4, which we would have said anyway, right? So our amplitude is 4. Okay? On a problem like this, we need the formula. The max and the min are different. So 5 minus, is that negative 1? Negative 1, thank you. And then, of course, half of 6 is 3. So your amplitude is 3. So if you can tell what it is, great. If you can't, there's a formula for it. And then, last one of these, find the amplitude looking at the function. What's the amplitude for A? Yes. 4, not negative 4. I can't tell you how many times I'm hearing people say negatives. Amplitude is 4. The negative is separate. Really what that says is this. What that really reads is f of x equals negative 1 times 4. That's what that means. 4 is your amplitude. Negative 1 tells us it's a flip. We just simplify it down to negative 4, but we know that they are separate values. Okay? What's the amplitude here? 1/2. Okay? Amplitude and period, we should be really getting very proficient at. Okay? One last concept to talk about on the last page. Any questions on this page? Say it one more time. We do. So if we were going to graph this, the amplitude is still 4, how high and how low we go. But the all those points will get flipped. So when there's a negative and there's a 4, it's 2 separate transformations. Okay, but you are right, we do flip it. But if I just ask you what the amplitude is, you go 4. That's it. What's the amplitude here? 1/2. Okay, amplitude is 3. Amplitude is 1. 1/2. All right, down at the bottom, example 6 and 7. We mentioned midline last week in one of the lessons. Here it is again. We're going to now learn how, because there's going to be many times we want to find the midline. Midline is exactly what it sounds like. It's the line that splits your graph right in the middle. So let me read to you. The midline of the graph of a sinusoidal function is the average, that's the word we need, of the max and min values of the function. The midline of the parent functions is just 0, right? If you don't move your graph up and down, if it's just the parent function where you're at the x-axis for middle, up, middle, down, middle, meaning there's no number at the very end, like a k, which I'm now calling d, if it doesn't move up or down, then your middle is just y equals 0, okay? But if the graph gets moved up or down like this one, the amplitude, a good way of knowing that y equals 0 isn't what your midline is there's no way that that is the middle of your graph, right? That doesn't make sense. It's going to be higher. And your max and your min are not the same value. You know your midline is not going to be at 0. So think about what the average is. If I said to you guys that your quarter grade, quarter 3 is going to be the average of 2 tests. I don't care about homework, quizzes, anything else. 2 tests, I'm going to average them together. All of you would know exactly how to do that in your calculator. You would take your 2 tests, what would you do to them? Add them and then do what? Divide by 2. Average, okay? That's exactly what we're doing here. So the midline formula is your max plus your min, add them together, divide by 2. It's just the average. Now, is anyone thinking that looks super familiar? It's super close to amplitude. The difference is one adds, one subtracts. For amplitude, you subtract the 2 of them, divide by 2. Scary how close they are. So separate those because you need to know the difference. So that's another formula I will add to our formula sheet. So far 3, I think. Okay, so let's do it. So the midline, I'm just going to call it mid, is, I can't see, let me find my key, the highest number plus the lowest number, max minus min divided by 2. So that's 4 divided by 2, which is 2. It's a horizontal line at y equals 2. Right here, we call it y equals 2. Horizontal lines are y. Horizontal. Remember hay and backs? So y equals 2. This one, let's do this one. The midline would be our highest number plus our lowest number divided by 2. Negative 6 over 2, which is negative 3. Can we have a midline that's negative? Of course we can. It's just a horizontal line. And it looks like it's in the middle. One more thing, guys, by the way, the amplitude of this graph, even though I didn't have you find it, the amp is 3. So if you use the other formula, and just something, no, look. From here to here, that distance is 3. So from your midline to your max is 3. What do you think the distance is from your midline to your min? It's also 3. So you can see, so if you're given a graph with the midline showing, you could just count from here to here to know your amplitude. You could skip the other formula. Okay, last thing. How do you find the midline from an equation? Well, it's really just knowing what you're looking at. This is that D letter I was talking about, D. So that's not for down. It's just the letter D, A, B, C, D. It's also known as K in your like polynomials, the parabola or whatever. And you already have been working with these. This means you're going to move your graph in what direction? Down 5, right? Well, if all your points move down 5, that ends up being your midline. It's so cool. It's so easy. You don't have to do anything. And this one is 4. So in this equation, you would have had a plus 2 at the end. And it moved all the points up 2. All your points moved up 2. Okay. That's it. Homework. which I'm going to start with you. Because number 5 and 6 are really important. If you are somebody that loves to work ahead, please stay with me and do 10 and 12 with me for sure. After that, I'll leave you alone. Okay? See, they didn't come in here. They never come in my room. Yes, I have a sign outside my door. It says periods 1, 2, 3, 6, 7, or 8 and 3 count. Is that an insult or a compliment, do you guys think?
It's a compliment, but it also means they're not on the radar.
I'm not on theirs? But that's good though, right? I don't want to be on anybody's radar. I don't want to be.
That's very good.
I want to coast through my last how many years with no issues. All right, so finding amplitude and period. Okay, amp. Guys, we are not going to get that wrong, right? Period is 2 pi unless there's a b. Yep, there's a b. It's pi. Simplify, period is 2. Right? We've been doing this for days. This is more practice of the same thing. What's the amplitude? 4. The period is 2 pi. Oh, unless there's a b. And there is. So I'm going to multiply by the reciprocal. Keep change flip if you want to, and then you end up with this, which is 4 pi over 3. Can't simplify that fraction, so just leave it. Amp is 2. Guys, don't forget, we're going to start seeing some new letters, new numbers, we're not really doing anything with. Don't forget what you already know, though. B is still that number in front of the x, okay? So who cares about that negative pi? It does not affect either of these parts of the graph. So that's 2 pi, and then is there a b value? Yep. Pi over 4. Guys, don't leave a fraction not simplified. 2/4 is 1/2. So there's half of pi right there. Good. Anybody having problems with one? No. Okay. All right. So for 5 through 8, but we're only doing 5 and 6, use 5 key points to graph each function from negative 2 pi to 2 pi. That's kind of new directions. Not kind of, it is new directions. We haven't seen one like that yet. Usually it says graph 1 cycle. We just do 5 points. So let's see what we have here. So number 5, what do we need for graphing? Amplitude, period. Right? That's what we need. Two pi, unless there's a b value. B value is 1, so the period is 2 pi. So what that means is it's going to take from 0 to 2 pi to make 5 points. So let's start with that, and then we'll come back to it. So this is a really basic graph. I'm not too worried about the x-axis. I'm just going to remember that sine is middle, up, middle, down, middle. So there is 1 period, 1 cycle of the graph. But we only went from 0 to 2 pi. We need to go from negative 2 pi to 2 pi. So we really just need to repeat this over here. It's always easiest to start left to right. If you try to go backwards, it gets confusing. Okay? So we're going to do the same exact thing starting at negative 2 pi. Middle. Sorry if I'm not hitting 2. It's so hard for you to see. I don't know. I hope that's 2. Middle. Up, middle, down, middle. So it just repeats, and that's an example of an odd function. Opposite quadrants are exactly the same. Okay? So from negative 2 pi to 2 pi, how many cycles did we graph? 2. That is 2 cycles, because we had to fill that space. Okay? Same thing here. Amp is 1 with a flip, right? And our period is 2 pi times 2, keep change flip, 1/2 becomes 2, is 4 pi. Okay, understand, this is the thing I was telling you can be tricky. Listen to me, my darlings. 4 pi is our period. That means all 5 points stretch from if we were going to do, like, for example, we could do from 0 to 4 pi. It's a very stretched out graph. But they didn't give us from 0 to 4 pi. They gave us from negative 2 pi to 2 pi, which is still 4 pi. It's distance. 2 pi plus 2 pi is 4 pi. So we have to stretch 5 points along here. So remember, cosine is up, middle, down, middle, up. So if we're going to flip it, it becomes down, middle, up, middle, down. Right? We start down. So at negative 2 pi, we're down. All the way at the end of the graph, we're down. So that takes care of the two ends. In the middle, we are up. And then, I shouldn't have said, the middle of our graph, so I confuse mids. And then we have our two x-intercepts in between that. So between negative 2 pi and 0 would be negative pi, and of course pi over here. Remember, your points should always be equally spaced. And that will give us our final graph. Nope, it says to graph from negative 2 pi to 2 pi. So here's negative 2 pi to 2 pi. And the period is 4 pi. So we had to spread it over a full 4 pi. In a situation like this, Annie, you could even, we're just using the graph they give us. So I think if I answer your question, it would be like, yes. But if you had to draw your own graph, for example, you could go, I'm just guessing it about the same. You could go repeat the graph. You could spread it from here to here. That's still using 4 pi of the graph, okay? But you could also do what we did, which is go out to negative 2 pi, right? Now, if you're saying use 3 pi, then we would go out to, that gets kind of complicated. Like negative 3 pi to 1 pi would be 4 pi. You know what I mean? So you want to just make it as easy as possible. When they give us a graph like this, we'll just use that space. It just makes it easy because that's a total of 4 pi. But yes, but it would be the same pattern. Because remember, it just repeats itself. So, well, and following the direction. So if in this case, it told us exactly where to graph, okay? Sometimes it could say graph 2 cycles. So then you could choose where your 2 cycles are. Yeah, like I said, you could go from 0 to 4 pi. You could go from negative pi to 2 pi. You could go from negative 3 pi to 1 pi. But you know what I mean? As long as your cycle is respected, meaning all 5 points go over 4 pi of the x-axis. Yeah. So this was very specific. Use from negative pi to 2 pi and graph that. Okay. Good questions. Yeah. Say it one more time. It does. The graph goes through 0, 0. Oh, the point. Why do you think, why? So, remember, regular cosine is up, middle, down, middle, up. It starts up. It makes like a U, okay? This is cosine flipped, so it's like an upside down U. Down, middle, up. All my ups became downs, all my downs became ups, or the other way around, whatever. So, yes, if this had been sine, positive sign, we'd start middle, up, middle, down, middle. If it had been negative sign, it'd be middle, down, middle, up, middle. Am I making sense? Oh, okay. So stop talking. Is that what you're saying to me? I got it. Yeah, got it. Okay. All right. Where's my key? Where's my key? There you are. Some of you might notice on your grades you got some extra credit that you weren't expecting. I forgot about it, but back when I checked your quiz reviews, you might have noticed I looked at the back to see if you did the FRQ. It wasn't required, but I went ahead and gave you extra credit if you did do it. So I marked it in my book here, but I didn't put it in the computer till today. That was almost like 2 weeks ago. So some of you, your grades went up because of that, just so you know.